What is up, everybody? Alex Louis here, giving you a little more knowledge on MATLAB. Last time we went over vectors, and today we're going to cover something called Colon notation. And there's a reason why I didn't cover matrices as an individual lesson, because they're all bundled up with colon notation and vectors. So let's get to it. So let's take a look at a real example of colon notation, and I'm going to give you a drawing here, and then we'll take a look at it in MATLAB so that we can practice as well. So let us say that we have, x is equal to, say, 1 colon 2 colon 7. So what this means is, it means that we're going to be able to build vectors with colon notation. And this first number means that this is where we begin. That's the first value that we're going to start at. This is the number of skips, and I'll show you what that means in a minute. And this is the end, right? The end range. So what this will do is it's actually going to give you a number, a vector, that is going to look like x equals 1, because you start at 1. Now you skip, okay? So you go 1, 2, 3, 4, 5, 6, and then 7. So now you have a vector with 4 columns, and this is a row vector. You're creating a row vector. And the values inside the vector represent whatever you fed it into the colon notation. So the number of skips is how many digits you're going to, how many count that you're going to skip from each value. In this particular case, our begin range was 1. We skip by 2, and we get to the end, which is 7. Now, if your end range happens to be less than the skip, right? So for example, let's say I have an end range of 6. Okay, at this point, if I go 1, 3, 5, 2 more would be 7, but 7 is greater than my end range, so my vector will now become only 3 columns with the values 1, 3, and 5. If you omit the skipping parameter, so this thing right here, okay, so we can also write this as perhaps, take this, I can say 1 colon and then 5, okay. It'll automatically only skip by 1. So what I would end up with is a row vector that looks like 1, 2, 3, 4, and 5. The default skip is going to be 1. Now, if I want to do a column vector, because this colon notation allows me to create or extract row vectors. Okay, if I want to do a column vector, okay, I can do something real simple here. I can just make it transpose. So what we can do is do that with a little colon, with a little apostrophe here, and that would create the following. So let me get rid of this. That will essentially create x is equal to 1, 2, 3, 4, and 5 as a column vector. Okay, as a column vector. And same rules apply if I do this with the middle parameter in there in the colon. Same rules would apply in terms of the skipping. Okay, and now I'm going to introduce the matrix. So a matrix generally, so I'll take this out, okay, and listen to always remember with this row colon notation, because we are going to do a lot of manipulation of a matrix. So when you have a matrix, the matrix is going to be one or more rows and two or more columns. So for example, let's say I do A is equal to, I do 1, 2, semicolon, 3, 4. Okay, and what this is going to do is it's going to create a 2 by 2. Okay, a 2 by 2. This and this represents one row. Okay, and this represents another row, 2 columns. Okay, so if we were to map this, okay, I'm just going to map it so you visually see it. It looks like the following. Okay, you're going to have a matrix that looks like 1, 2, and then because of the semicolon represents that it's going to be a new row in the matrix, so it's going to be 3, 4. Okay, so this is going to be a 2 by 2 matrix. Okay, we can see this is a 2 by 2 matrix. Okay, now here's a question. How would you create a 2 by 3 matrix? So we want to create, let's take this out. We want to create a 2 by 3 matrix. How would I do that? So let's do B. Okay, so how would I create a 2 by 3? So remember, this represents how many rows, and this represents how many columns. Okay, so sorry, it's supposed to be an N. Sorry about the funky colors. It's my daughter using my computer for her virtual lesson. So okay, so remember, this is a 2 by 3. Okay, so 2 rows and 3 columns. Okay, so what we would do is, remember, the semicolon represents the separation of rows, right? So that means we would say, let's do 5, 6, 7, right? Colon, semicolon, 8, 9, and 10. Okay, which essentially, remember, this colon separates the rows. We have 2, right? 1, this is the first row, and this is the second row over here. Okay, and then now we know we have 3 columns, right? So this would essentially look like the following. It would say, as a matrix, we'd have 5, 6, 7, and then this would have 8, 9, and 10 over here. So how many rows do we have here? We have 2 rows. Okay, I can write over here 2 rows by 3 columns, right? So column 1, column 2, and column 3. So that's a 2 by 3 matrix. Okay. Okay. So far in this lesson, we've introduced colon notation, how to create a row vector, column vector, okay, automatically. And we've also introduced the concept of creating a matrix. Okay, creating a matrix. Now, can you create a matrix using colon notation? Of course you can. Okay, so in the next few lessons, we're going to take a look at how to manipulate matrices using this new concept of colon notation. Because if you look at this particular example, how much are we skipping by each value, right? So 5, 6, 7, I can easily do that with a colon notation expression. And 8, 9, 10, I could also do that with a colon notation expression, where I would have a begin range of 8 and end range of 10 for my second row, And for my first row, I would have a range from 5 to 7. Okay, I wouldn't have any number of skips because we are only going by 1. Okay, so keep that thought in mind, and then we will I'll see you on the next video.